Diesel knock. It is the phenomenon occur in the diesel engine. If the ignition delay period is long, a large amount of fuel will be injected and accumulated in the combustion chamber. The auto ignition of this large amount of fuel may cause high rate of pressure rise and high maximum pressure, which may cause knocking in diesel engine. A long delay period not only increases the amount of fuel injected by the moment of ignition but also improves the homogeneity of the fuel air mixture and its chemical preparedness for explosion type of self ignition similar to detonation in SI engines. Methods of controlling diesel knock. Now, diesel knock is a abnormal combustion where we have observed if there is a time required or time taken for the ignition is more than due to larger amount of fuel available for the combustion, large amount of pressure is generated and knock observed. Now, what are the different methods to control the diesel knock? The first is high charge temperature. If the charge temperature is high and enough, then there will be shorter ignition delay period and no accumulation of fuel will be observed in the combustion chamber. Then high fuel temperature, good turbulence, a fuel with short induction period and by using ignition accelerators like amyl nitrate. Now we will compare the phenomenon of detonation in SI engine and knocking in CI engine. Detonation occurs near the end of combustion, whereas we have observed that knocking occurs near the beginning of the combustion, that is, at the end of first stage of combustion. Detonation in SI engine is of a homogeneous charge causing very heavy rate of pressure rise and high maximum pressure, whereas knocking in CI engine is of imperfectly mixed charged and hence the rate of pressure rise is normally lower than that in the detonation of IC engine. Here, in case of detonation, pre-ignition may occur. We have observed that these hot spots are developed near the spark plug and even before the spark ignition, the ignition may occur. Here in case of knock, fuel is injected into the cylinder only at the end of compression stroke and there is no question of pre-ignition or premature ignition. Detonation in SI engine is easily distinguished from the normal combustion, whereas knocking is not easy to distinguish from the normal combustion. In case of SI engine detonation, large cylinder promotes detonation. If the size of cylinder is larger, then the charge which is available at the end of combustion chamber, it ignites before the flame actually reaches there. So large cylinder give the chances or it tends to have the more chances of detonation, whereas diesel knock is reduced with increase in size of cylinder. In case of diesel engine, if the size of cylinder is more, no accumulation of fuel droplet will happen at the beginning of the combustion. The fuel droplet will be spread throughout the combustion chamber. So larger cylinder size is desirable in CI engine. Compression ratio in SI engine is limited by the detonation. We know if the more the compression ratio, more will be the temperature, and if more will be the temperature, chances of detonation are more. Whereas in CI engine, higher compression ratio causes laser ignition delay and hence lesser possibility of diesel knock. In case of diesel engine, we want high temperature so that it will reduce the ignition delay. So if we want high temperature, the compression ratio should be as high as possible. So here in this diagram, we may clearly see the detonation actually happens at the end of combustion, whereas the knocking happens after the first stage, that is ignition delay period, the knock happens. So this is the abnormal combustion in CI engine. Now we'll see the different types of combustion chambers that are used in CI engine. So the types are open combustion chambers, divided or turbulent swirl chamber, pre-combustion chamber, air cell combustion chambers. Open combustion chamber. Now, what are the open combustion chamber? So, in open combustion chamber, the method of swirl used is induction swirl. In induction swirl, flow of air is directed towards the cylinder during its entry. An open combustion chamber is one in which combustion space is essentially a simple cavity with little restriction, and there are no large differences in pressure between the different parts of chamber during the combustion process. Now, divided or turbulent swirl chamber. So the method of generating swirl in the divided chamber is by compression. Compression swirl is one in which air is forced through a tangential passage into a separate swirl chamber during compression stroke. A divided combustion chamber is defined as one in which the combustion space is divided into two or more distinct compartments between which there are restriction or throats small enough so that considerable pressure difference occurs between them during combustion process. Pre-combustion chamber. The type of swirl used is combustion induced swirl. A pre-combustion chamber consists of pre-combustion chamber or antechamber connected to the main chamber through a number of very small holes. Pre-combustion chamber contain 20 to 30% of clearance volume. Pre-combustion chamber has multi-fuel capability without any modification in the injection system in the type of swirl used. That is, combustion-induced swirl. Swirl turbulence is created by use of initial pressure rise due to partial combustion. CI engine combustion chamber. Air cell combustion chamber. The type of swirl used in this combustion chamber is combustion induced swirl. Here there is no organized air swirl. The advantage for this type of combustion chamber are the maximum pressure on the main chamber is fairly low and hence it gives smooth running and easy starting. This type of combustion chamber is most suitable for comparatively small engines of medium duty where relatively high fuel consumption can be tolerated. So here direct injection, indirect injection. So this is direct injection. This is compression swirl. We'll see. You may check direct, indirect injection where here the injection happen and then after mixing it is given to the cylinder. So these are the types of combustion chamber. Direct injection chamber, good supply of oxygen to the combustion chamber, lower surface area, high efficiency, lower fuel consumption, and good cold starting ability. Now, the drawback inaccurate setting of valve can damage piston, engine runs rough, injector nozzle hole may get blocked, high injection pressure are necessary. Ricardo compression swirl combustion chamber minimize exhaust gas odor, relatively low injection pressure, reduced delay period. Drawback cold weather starting problem, inefficient scavenging, slightly more fuel consumption compared to direct injection of pre-combustion chamber. Advantages blockages due to carbon deposit of pintle type nozzle is eliminated. Lower injection pressure is required, low quality fuel can be used, and smooth engine operation. Whereas drawback heater plug is required for flow, cold starting, low thermal efficiency, high fuel consumption. Air cell or energy cell combustion chamber advantage minimum shock loading of working component due to high degree of control combustion, reduce exhaust gas pollution, relatively low injection pressure. Drawback starting difficulty when cold, hence glow plug is necessary. Inefficient scavenging of the energy cell, cost cylinder head, complicated molding machine involved. M combustion chamber advantage low peak pressure, low rate of pressure rise, low smoke level, multi-fuel capability. Drawback low volumetric efficiency, cold starting, required glow plug at starting and idling condition of hydrocarbon emission may occur. So in next class we'll see the comparison of SI and CI engine. Thank you.